What do you know about life 1 billion years ago? How about 2 billion years ago? Or 4 billion years ago? Exactly. You know nothing. And we don't blame you, because there are huge gaps in the geological record of our planet. So today, let us take a journey back through deep time and revisit some of the pivotal moments that helped make the world what it is today. This is the story of the forgotten billion years of Earth. Between 4.6 and 4 billion years ago, our young planet was a violent place. Earth had not yet reached its final form. It was still growing, bombarded by asteroids, and bombarded by a lot of other stuff. A Mars-sized protoplanet called Theia is thought to have crashed into it. This giant impact not only gave us our precious moon, but also delivered a bunch of volatiles to Earth's surface. These included water vapor, carbon dioxide, and nitrogen, which combined with other elements already present to form Earth's first oceans and atmosphere. In the searing heat of this chaotic era, known as the Hadean, which lasted until 4 billion years ago, Earth's surface was constantly reshaped by volcanic activity and meteorite impacts. But despite all this destruction, the conditions were just right for life to start. Maybe. The oldest evidence we have for life so far dates back to 4 billion years ago. However, scientists have argued over whether these ancient structures are actually fossils or just inanimate rocks. One thing's for sure, though. During the Hadean, Earth was a very different place than it is today. Continents didn't exist, at least not in the modern sense. Instead, the planet was mostly molten rock covered by a thin layer of solid crust. That's why we haven't found any rocks older than 4 billion years on the surface of the Earth. They've either been destroyed or they're buried deep in the planet. And because there was no ozone layer to speak of back then, Earth's early crust formed in a constant radiation. So it was definitely a crazy time to be alive. But if life did somehow manage to start in this harsh environment, it would have been incredibly resilient. After the Hadean came the Archean, which lasted until 2.5 billion years ago. During this period, Earth began to look more like itself. The first stable continents began to emerge from the churning ocean of magma. Oceans also became more like the ones we know today, salty and full of water. In fact, most of the water on Earth today was delivered by meteorite bombardment during the Archean. As Earth cooled, minerals in the rocks began to weather, creating chemical conditions that allowed liquid water to exist. And with the emergence of liquid water, the stage was set for the origin of life as we know it. But here's the thing. While the Archean is considered the dawn of life on Earth, we know surprisingly little about it. Again, there's a gap in the fossil record, and we don't have much hard evidence of what was happening back then. We do know that the first major event of the Archean was the Great Oxidation Event. Around 2.4 billion years ago, photosynthetic bacteria called cyanobacteria began releasing oxygen as a byproduct of their metabolism. At first, this oxygen reacted with the reduced metals in Earth's atmosphere to form new compounds. But as the amount of oxygen increased, it started to accumulate in the atmosphere. Today, our atmosphere is about 21% oxygen. But until the Great Oxidation Event, Earth's atmosphere was probably devoid of free oxygen. So this sudden change was dramatic. It was a disaster for many early organisms that couldn't handle being in an oxygen-rich environment. Most of them died off. This mass extinction paved the way for organisms that could use oxygen for respiration, allowing them to thrive in the newly aerobic world. One of these organisms was the first eukaryote, an organism with a nucleus, which appeared in the fossil record around 1.6 billion years ago. The rise of eukaryotes laid the foundation for all complex life on Earth, including plants, animals, and fungi. However, before this, the Archean saw the rise of the first prokaryotic cells, which lacked a nucleus. These cells, which include bacteria and archaea, appeared in the fossil record around 3.7 billion years ago. Some of these ancient cells were autotrophs, meaning they could produce their own food from inorganic sources. Others were heterotrophs, meaning they consumed organic matter for food. Together, these early cells formed the basis of the first ecosystems. But we don't know much about them, because again, there's a gap in the fossil record. We do know that some of these early cells lived in environments that would be hostile to most life today. For example, many of them thrived near undersea hydrothermal vents, which are cracks in the seafloor that spew out superheated water. These vents are rich in chemicals, such as sulfur and iron, which can support life independent of sunlight. This suggests that life may have originated near these vents rather than in surface waters. But wait, there's more. Our planet also experienced several mysterious global-scale glaciations known as snowball Earth episodes during the late Heavy and Archean eras. The idea that Earth froze over completely is pretty crazy. And while it's not universally accepted by geologists, the evidence is pretty compelling. There are glacial deposits found all over the world that date back to this time period. And computer models suggest that if all the continents were close enough together, they could have formed a single ice cube. Proponents of the snowball Earth hypothesis believe that oceans may have frozen from pole to pole, leaving only small pockets of open water. But the details are still debated. What is not up for debate is that snowball Earth had a profound impact on the history of life on Earth. The dramatic environmental shifts forced life to adapt or die off, leaving behind a legacy that we can still see today. For example, some scientists think that the snowball Earth events triggered the first mass extinction, which wiped out a significant portion of life on Earth. Other researchers argue that it was the catalyst for the Great Oxidation event by concentrating oxygen in the atmosphere. Either way, these episodes were critical in shaping the course of evolution on our planet. And now we come to the billion-year gap, a time period spanning from 1.8 to 0.8 billion years ago. The name says it all. Geologically speaking, this era was relatively stable, but biologically, it was anything but boring. New species appeared in the fossil record, but the overall pattern of evolution was slow and steady, which made it a perfect time for life to kick back and relax. Maybe watch some TV, play some video games, work on that novel you've always wanted to write. Not exactly. The fossil record shows that innovation picked up toward the end of the gap, setting the stage for the Cambrian explosion. So perhaps the purpose of the boring billion was to prepare the stage for what was to come. It was like a comedy setting up a punchline. But what exactly caused this explosion of life? Scientists have put forward several hypotheses. One theory is that it was triggered by an increase in atmospheric oxygen levels, which may have provided the energy needed for larger and more active animals. Another theory is that it was caused by an increase in atmospheric carbon dioxide, which led to higher temperatures and more favorable conditions for life. Yet another theory is that it was driven by changes in Earth's geology, such as the formation of new mountain ranges or the breakup of supercontinents. Whatever the cause, the effects were profound. The Cambrian explosion marked the beginning of the Paleozoic era, which lasted until about 248 million years ago and saw the rise of most major animal groups. It also marked the end of Earth's forgotten billion years. But before we get to the Cambrian explosion, let's talk about the pre-Cambrian. This period of time lasted from about 540 million years ago to about 250 million years ago and was named by Sir Charles Lyell in 1828. He chose the name because he believed that there was no trace of any life before the Cambrian. But that's not true. The Precambrian saw the rise of some of the earliest known animals, but unfortunately, we know surprisingly little about it. Again, there's a gap in the fossil record. The reason we know so little is that soft-bodied organisms like jellyfish and worms do and preserve well in the fossil record. So we have little information about the diversity and complexity of life during this time. However, we do have some fascinating clues. For example, There are enigmatic fossils that have been found in South Australia, dating back to about 600 million years ago. These fossils, known as the Ediacaran biota, represent a group of strange, often immobile organisms that don't resemble any modern animals. But even less is known about these creatures because, again, there's a gap in the fossil record. So the exact nature and significance of the Ediacaran biota remain a mystery. And then finally, there's the Cambrian explosion, a period of rapid diversification of life that took place about 540 million years ago. It was a pivotal moment in Earth's history because it marked the beginning of the Paleozoic era and the emergence of most major animal groups. The Cambrian explosion was a remarkable event in which the vast majority of animal phyla appeared in the fossil record within a relatively short period of time. Before the Cambrian, life on Earth was relatively simple and consisted mainly of single-celled organisms and some small, multicellular creatures. But after the Cambrian, the seas teemed with creatures like trilobites, brachiopods, and mollusks. The causes of the Cambrian explosion are still debated, but it's clear that it was a critical moment in the history of life on Earth. It set the stage for the evolution of complex ecosystems and the emergence of new adaptations and behaviors. And it brought an end to Earth's forgotten billion years. We hope you enjoyed learning about the long-lost world that existed before the Cambrian explosion. It's amazing to think that so much of our planet's history is hidden from view, but it's also exciting to know that there are still so many mysteries left to solve. Thanks for watching.